of thumb still apply. Multiplication binds with higher priority than plus, so realize you might sometimes in code need some parentheses. Now let's finish up printf. So printf we've used %s thus far, but there's other format codes. If you want to spit out a character, you don't say %s, you say %c if it's just a single character. If you want to print out a decimal digit, you say %d, just a human-friendly number. If you want to print out a floating point value, you print out %f, whether it's a float or a double. And this just means that printf will take care of putting the decimal point aesthetically wherever it belongs. And as we saw the other day, it will also decide for you, if you don't specify, how many numbers to show after the decimal point. And then lastly, and just as an aside, there's also this crazy one, LLD, long decimal. So this is actually important because if over the next few weeks you use, for instance, a long, because you really want lots of bits to store a big number, but you try to print that number using %d, it's going to look completely wrong. It's going to be negative, it's going to be smaller, and that's because printf is going to be misinterpreting the bits and essentially only looking at 32. So if you want to tell something like printf, I'm using 64 bits, just realize and refer back to things like these other format codes. So those are just some building blocks. Let's actually do something with them. So just as in Scratch we had conditions, so do we have them in C. And we saw a glimpse of this on Wednesday. And so the next several examples are really meant to just translate what was more user-friendly and puzzle piece-like to something more deliberate, something more cryptic, but will be increasingly familiar. If you want to express the notion of a condition, if this is true, do this. Well, the syntax in C is to say if, space, open parenthesis, and then something. We'll fill in the something in a moment. Open curly brace, and then do this. Now in C, this / actually represents something special. For those already familiar, it's a comment. So a comment just means this is not actually code. It's just English or whatever language I personally speak that's a notation to myself as to what's going on. You might not have noticed these in Scratch, but if you right-clicked on the scripts area, you could actually paste in a little yellow sticky, like a Post-it note, and that was the equivalent in Scratch of just notes, comments to yourself. C also has this. C also has another syntax that you might see in books and my own examples, whereby you can do /*, */. The advantage here is that this syntax can actually span lines, and you can say something like and this, and that's all a comment. Whereas the // only applies to one line. So just realize they're two different styles, and doesn't so much matter which one you use so long as you're ultimately consistent. Now this only lets you do something or not at all. Can we do more? Pound or sharp do not work in C. So the only two options in C are // and /*. So what if we want two options, two forks in the road? We can go if this is true, do this, else do that. And just like in Scratch, if we start embedding these things, we can have three forks in the road. We can say if this, do this, else if this condition, do that, else do this other thing. So again, same ideas in Scratch. We just need to express them now with a keyboard, but the ideas are the same. Yeah? Is there a way to do automatic formatting?
Yeah, like if you start, like, for example, typing like /*, then like hit enter, then it like basically allows it for.
Good question. So those of you with prior backgrounds might have used tools that actually kind of fix any messiness, any sloppy code that you write for you. gedit does not do that. A program called Eclipse that we'll eventually use does that. And for those more comfortable are welcome to use other tools if they'd like. But for now, the goal is to actually get you yourself into the habit of writing good, clean code until the tools will actually start making this easier for us. So in short, in gedit, no, you need to be hitting the tab key or space bar. So Boolean expressions. Just as in Scratch, you can say if this is true and this is true, do something. Or you can say if this is true or this is true, do something. And as I recall, those blocks are generally green in shape, and they've got little diamonds if you used any of these in your program. To express that same idea in C, you can say if this condition is true or some other condition is true, then do this with whatever's inside the curly braces. Now the vertical bar is just, again, C syntax for saying or. A single vertical bar in a few weeks we'll see means something else. So this is just the equivalent of or. The equivalent of and, meanwhile, is this, and. And so now with this syntax, we can express doing something if only if two things are true. So let's actually try to use a program that leverages these. Let me go ahead and close hello.c. I'm going to go into one of the prefabbed examples for today, which is available as a PDF and also as downloadable code on the course's website under lectures. And I'm going to open a file called conditions1.c. And it looks a little something like this. Now, at the top of the file, there's actually a whole lot of text, but this is just a comment. And the fact that I've hit the asterisk this many times, this is just a human convention to kind of make super clear this is not a comment, not only a comment, this is a pretty huge comment. You better read this, but this is just a matter of style. You don't necessarily need to adopt the same convention. What's important, though, is that the first character at top left is /*, and the very last one involved is //. All the other stars are just an aesthetic curiosity. But here I just have some comments. So let's scroll down to the more interesting part. Notice that I'm using apparently the CS50 library. I'm using standard I/O, so I can preemptively guess that I'm probably calling something like getString or getInt. I'm using something from the library, and I'm probably also using what other function? You can kind of infer the answer is right there. Right, printf, right? So I included standard io.h because I'm calling printf. But otherwise, this is familiar except for a few new features. So let me scroll down here, and here's now a more compelling role of comments. Thus far, just saying do this is kind of useless. It's meant just to be a placeholder. But now, another matter of good style, quote unquote, and we'll reinforce this in section over the next several weeks, is to not just write your code and leave it to the reader, whether a TF, a colleague, or you 1 month hence, to figure out what the heck you meant by your code. The best habit to get into from the start is to actually make a note to yourself in 1 line or 2 or 3 or more what's going on, so that you yourself, honestly, the next morning can skim your code and realize, oh, that's what I was doing and why. Moreover, someone else in the real world can also understand what you're doing. So what am I doing here? I'm asking the user for an integer. How do I do that? Well, as before, I just have this aesthetic of I'd like an integer, please, colon, space, but I could have said anything there. The interesting part is this. So what's going on here? Well, before I used getString, and getString returns, so to speak, a value. It figures out how to get all the user's keystrokes. It then bundles them up together and then hands me a value. But if I want to keep that around, I need to put it in a variable. Well, in Scratch, to create a variable, you click that button, like create variable, and you give it a name. Same thing in C, but you have to be more explicit. You have to give the variable a type. And you have to say, is it a string? Is it an int? Is it a float? And so the key difference here in C is that you literally have to say that. I want a variable called n. Its data type, per this keyword to left, is an int. And what do I want to put into that variable? I want to assign it. So the equal sign means assignment, whatever it is that getInt has gotten from the user. Now, just as an aside, because you'll see other syntax still, these two things, getting in the int and saving the int, do not all need to be done in the same line. It is not uncommon to see this instead. I'm going to put a semicolon there, and then on the next line or somewhere else in my program, I can do this. So the takeaway here is that you always have to declare, so to speak, a variable. And to declare a variable just means tell me its type, tell me its name, semicolon. That's it. But to assign a variable a value, you have to eventually use the assignment operator, the equal sign. But notice that you don't redeclare what? You don't say int again. You already told the compiler what it is. It would be redundant to say what it is again. And so you don't need to say it again. Now, why use version 2 versus version 1? You know, frankly, again, as a matter of style, and this is something you just kind of pick up on your own, it just kind of looks a little ugly, right? I'm a little anal, and I just kind of like the elegance of this one line of code. And so when we say code is elegant or clean, it's these little details where your code starts to get more compact and just more readable. And this, too, is a style that we won't enforce on you, but rather encourage exactly what conventions you adopt. Now, what about here? This is the meat of the program. Analyze the user's input somewhat inaccurately. Now, here's the syntax for this. If n, which again is the int that the user just typed, is greater than 0, print out, you picked a positive number, \n. Else print out, you picked a negative number. Now, I disclaimed in parentheses, somewhat inaccurately. Why? What's the bug in this program? OK, good. So 0 is obviously not considered. So if I type 0, what's it going to say? You picked a negative number. And that's not true. 0 is neither negative nor positive. So we can fix this. So I can actually do something like else if, let's say, n is less than 0, say this. And then otherwise, let me go ahead and just copy and paste. and then get rid of the redundant condition there. You picked, let's say, you picked 0, and now I have 3 branches, the last of which is the catch-all, but the only case left to catch is 0, so this would now seem to work. But also, I seem to be violating the previous slide. What piece of syntax have I omitted here? Yeah, those curly braces. Remember, in every prior example in black and white, I had if, and then a condition in parens, open curly brace, then some comment like do this, close curly brace. Well, it turns out this is OK if, and only if, all that you're doing inside of the fork in the road is one thing. If you only have one line of code, frankly, it just feels kind of lame to add 3 lines in total just to say one thing. So this is correct. And frankly, when your code gets more fancy, this is actually more readable because it makes it even more clear what's inside this fork in the road. But as it is, it like triples the size of this block of code, and it's just not necessary. So this, too, is a matter of style. But notice this would be wrong. Printf, oh, by the way, hi, or something like that. This is now wrong, and the program will not even compile in this case, because even though I've indented it, that's great. You can indent things all you want. If you've used more than one line of code and no curly braces, the compiler is actually going to complain. So let's go back to the correct version. Let me get rid of this, and I'll leave in the 3rd fork in the road. Let me go down now to this file. Now, this happens to be a file I created in advance, and I put it in a directory called lectures, in a subdirectory called 1 for week 1, and then in a subdirectory called source, src. And now if I type ls, here's a whole bunch of code that we'll be playing with this week and next. Let me go ahead now and say make, what was the name of this program? Conditions 1, enter. That looks good. Let me go ahead and run conditions 1. I'd like an integer, please. Let's say 123, enter. You picked a positive number. How about -3? You picked a negative number. And how about 0? So it seems to have caught that. So we now have conditions. Yeah? Sorry, a little louder? Ah, a good question. So what if I try to feed the program a float, which is clearly not an int, a float being something with a decimal point? And again, recall that I'm using getInt. Well, let's see. And again, this too should be a recurring theme. Like when in doubt, and obviously it's fine now if you don't have your own computer out, but when in doubt, just try it. The worst thing that can happen is it will break something, and that will in itself reveal the particular answer. So I'd like an integer, please. How about 1.99? Enter. So it says retry. So one of the things the CS50 library does too for you is that if you're calling getInt, it's only going to let you get an int. If the user is difficult and types in something stupid like monkey, it's also just going to reject it and automatically say retry. So it does these kind of checks for you. If I wanted to actually get a float, I'd have to actually use getAfloat. And now just a quick tip. How do I get rid of this program? I'm kind of done executing it. Control-C will abort. Yeah? Good question. If you were to use multiple lines of input, as in the case of, let me go back to hello, where I say something like, hello, my name is David, enter. So getString can only get one line of string. So to get multiple lines of input, we'll actually need more sophisticated techniques. We cannot use getString, but that's fine, because at that point, these training wheels will be off. All right, so we now have conditions. We now have Boolean expressions. And again, a Boolean expression, to be clear, is just something in parentheses that evaluates or is true